So welcome to the latest in the Somerford series of podcasts focusing on areas of significant contemporary interest to the, not just to the cybersecurity community, but more broadly to the data and information community. Today, I have to say I'm delighted to be joined by Ewald Munz, who is dialing in from Germany. Ewald, a very good afternoon to you on this very hot summer's day. Ewald is the Splunk lead for OT specifically in the manufacturing space. So what over the next sort of 25 to 30 minutes, what we'll do is we'll just go through a series of discussions with Ewald to get his perspective. Ewald, how are you? Okay?
Yeah, hi, John. Thanks for having me. I think here in Stuttgart in Germany is as hot as in the UK today.
Brilliant. Excellent. Well, hopefully we won't descend into a wet mess. And the conversation will inevitably be as interesting as I anticipate it will be. So we talk, just to sort of kick us off then, well, for the uninitiated, primarily myself, I have to say, when we talk about OT security, what we're talking about is essentially I guess it's the intersection between sort of industrial systems, cybersecurity, data analytics. More specifically, I mean, we mentioned the manufacturing industry, but it has its application across the critical national infrastructure, across utilities. And can you just expand on all of that? What does it actually mean, please?
I think that's a very good question, John. And if you have asked me this question maybe 10, 15 years ago, I believe the answer would have been different, because in the past, we would say OT, meaning operational technology, maybe would have not been, let's say, the best friend of IT, the information kind of technology. They used to be quite a separate worlds, I would say, with different kind of responsibilities, so quite, let's say, siloed. But nowadays, I would say it has been quite a journey. So we talk about now IT-OT convergence. Used to be quite a buzzword. For some, of course, it's also quite a normal nowadays. But I would say now IT is very much also part of the OT, and OT is very much part of the IT. And of course, there are now mixed teams with, let's say, with cross-functional kind of responsibilities, and talking about the data and talking about AI, talking about how manufacturing evolves. This kind of, let's say, closely interlinkage between IT and OT is clearly a necessity, I would say. So OT technology is no longer, let's say, the separate kind of silo it used to be.
Right. And one of the other areas that I think that is becoming increasingly important for business leaders, of course, is resilience. Resilience in supply chains. I mean, given the macro political climate, it is really difficult to be able to sort of predict and to assure those supply chains with the sort of regularity and the frequency, and I guess the certainty that business leaders require. Could you sort of explain how Splunk OT capability, how that helps play into that space for me, please?
Yeah, I mean, you touched, I would say, a very important point. Resilience, I would say, is clearly the number one topic of manufacturers. And this was underlined by a recent World Economic Forum studies. And they clearly highlighted that resilience is not only, let's say, a key competence today, it will be even more important in the future. So resilience being very agile, being very flexible to all the changes and uncertainties ahead. And of course, let's say number one challenge for manufacturers these days is the extremely high number of cyber attacks. So manufacturing is by far the number one industry hacked by cyber criminals. So clearly they have to develop some kind of resilience here. And then secondly, you mentioned it before, all the current geopolitical kind of uncertainties and tensions and developments. So clearly manufacturers have to be very flexible and agile and be prepared short notice. They need end-to-end visibility across their business processes. And of course, the data is crucial here. And lastly, of course, not surprisingly, the role of AI. Of course, things have developed at a very, very rapid pace. Of course, starting from Gen AI, now, of course, agentic AI is talk of the town. And in future, of course, people start to talk even about physical AI, so meaning that the robotics AI behind it. And you may know this long-running joke or even fear among plant managers. So they used to say that in the factory of the future, there are only two living beings, a dog and a worker. And the job of the worker is to feed the dog, and the job of the dog is to keep all humans away from the machines. So that the challenges ahead, and you need resilience for all of this.
Yeah, and of course, business leaders are becoming under increasing pressure to use AI more and more, aren't they? But of course, that will bring with it increased risks, inevitably, I'm assuming.
Of course, yes.
And it was interesting actually. I think only this morning I listened. There was a thing on the radio. There's reporting out from recruiters who are reporting full reductions in the number of vacancies for undergraduates because businesses are becoming or making more use of Gen AI, and therefore there's another risk there. But that's probably a subject for a separate conversation, I suspect. So when we go back to OT, can you sort of outline for me how Splunk would be typically deployed in sort of like an OT environment? So whether on-prem versus edge versus cloud, could you expand on all that for me?
Yeah, so I would like to highlight that Splunk has a very special and I would say unique kind of approach how to help our customers in the manufacturing space. So we do not necessarily highlight, let's say, features and functionalities. We really highlight the value we can bring our customers, and especially the value how to build their resilience. And in this context, we're speaking about so-called business outcomes. And of course, there are many business outcomes, but we're focusing on four major or most important business outcomes for our customers. Number one, most importantly, IT and OT security. And I would say the most important word in this sentence is and. So not IT and OT security separately, but IT and OT security together to have this complete visibility across IT as well as OT environments. And of course, with a specific focus, let's say, on the OT environment, let's say with a dedicated focus on OT vendors, with a dedicated, let's say, OT security use cases. And I would like to highlight here especially perimeter monitoring. And you may know that air gapping, basically physically disconnecting machines, used to be quite a safe kind of a methodology to prevent cyber attacks. But now let's say with Industry 4.0, with all devices being interconnected, air gapping is no longer safe. And we can clearly show, for example, plant managers that there's also traffic where there's no traffic supposed to be. So to bring this visibility into OT environments. And another, I would say, key value is here, so-called the risk-based alerting, because noisy SOCs, meaning basically false alerts, are a key challenge in OT environments. So some customers report sometimes 2,000, even maybe 10,000 false alerts per day. And obviously, it's humanly impossible to deal with this on a daily basis. Getting crazier. So you need automation, security automation for this to deal with this kind of challenge. So a lot of value in the IT and OT security space. And secondly, so-called next generation operations. And here I would like to highlight energy management, because especially say in the Western world, the rising energy prices and the regulation they really put the focus on energy management. And we as a data platform, we focus on the metrics, obviously energy costs. Yeah, so we help our customers to reduce their costs, to improve their energy efficiency, and also improve their carbon footprint. So very big focus on energy management. And there's this recent public success story with the Bosch Rexroth. For example, we helped them reduce the energy costs by 20 to 30% in their model fab here in Ulm in Germany. Yeah. So big focus on energy management.
Well, that's interesting. I mean, the UK government have just released its industrial strategy, and there was a lot of emphasis in there on energy costs, of course, because it's a major factor for energy consumption within manufacturing. I mean, on that then, what in order to sort of to build in those sort of that resilience and that sort of visibility, if you like, what are the most common data sources in OT environments that Splunk would typically ingest then?
That's a very good question. Of course, the answer is it depends per use case, obviously. So, for example, if you look at security or OT security, one of the most important data sources is obviously firewall data and event data. We can clearly, let's say, distinguish between must-have data sources and nice to have data sources, but obviously it's like a journey for manufacturers. And of course, the recommendation is to start with the must-have data sources. And in the case, let's say, for example, for energy management, it's obviously the energy consumption data of the individual machines, of the control systems, or let's say of the data centers, the on-premise data centers of manufacturers. And these data sources we correlate also with external data sources, which is actually the power of Splunk, this kind of correlation capabilities. And in the case of energy management, for example, we correlate it with the so-called a carbon intensity, meaning how many grams of CO2 per kilowatt hours are in your power mix. Yeah. And with that, you get the carbon footprint and all the prediction and the machine learning behind to really draw conclusions and optimization. So not just data insights, the actual visibility, but to optimize based on these insights.
I mean, that's really interesting. I think, and just picking up on a point you made earlier about cybersecurity and maintaining a theme about resilience. How is Splunk used to improve OT cybersecurity posture when you're dealing with, ransomware or supply chain attacks and those sort of things? Could you sort of talk me through that? Because I think it very much leads its way into what we were talking about with resilience and with understanding how for business leaders, providing them with that visibility that they want to. How does that sort of work?
Yeah, so I'd like to use two examples. So one example of visibility and one example of automation. Yeah. So coming to example of visibility. So typically, let's say for any kind of manufacturing companies, they would say quite mature in a IT scene, covering, let's say, if you look at the Purdom model, the office zone, so level 4 to 5. Yeah. And now what we're doing now with OT security, we increase this visibility. So we are diving down deeper down at the Purdom model, let's say up to level 2 or so, yeah. And all, let's say, the other market vendors active in the OT security space. I mean, we're talking about like of course, Cisco Cybervision or Clarity or Nozomi or Armis, the many vendors, they're all our, let's say, good friends, and we simply ingest them as a data source, and as such we can provide this holistic, unified visibility from level 0 to 1. Yeah? So this unified visibility. And then secondly, the example on automation. So I would like to use the example of the risk, the automated Splunk attack analyzer. Yeah? Because for many of our customers, security talent is hard to find on the market. It's expensive. So the obvious solution is automation. Yeah? And with this Splunk Attack Analyzer, we can basically automatically detect the virus and the cyber attack, and also, let's say, do the measures automatically. Yeah? So automation is the key here. So visibility plus automation in the case of a cyber attack. Because I would say the brutal reality is it's like an earthquake in Japan. You cannot avoid a cyber attack. It will come one day. Just be resilient and of course survive it, and of course come out stronger.
Yeah, of course. And then what about compliance? What about security standards? I mean, what security standards are you compliant with? I mean, NIST, presumably, is that fair?
Yes, of course. I would say NIST 2 is the latest kind of regulations in a number of regulations, whereas, let's say, all the regulatory authorities, they're trying to softly push the companies to, let's say, to modernize their security posture. But actually, of course, there's a there are many paragraphs and text, but if you simply translate it, it basically means manufacturers need unified visibility across their IT and OT environments. That's about it. Sure. and here we can help them. And this regulation is actually quite a sharp sword, because, let's say, if in the case of a cyber attack, if companies have not modernized their security systems, their C-level is basically personally liable, so they have to pay from their own pockets if they have to pay ransom and all this kind of things.
All right. Well, there's a good deterrent, if ever I've heard one. And then you mentioned the unified visibility. Presumably, Splunk has that ability to correlate OT security data with IT data to provide that complete unified visibility, does it?
Yes, exactly. Yes, that's the key, one of the key strengths of Splunk. Yes. Yeah.
Okay. So then, sort of moving slightly on a bit onto the sort of data collection space. Then, so what about legacy systems, legacy OT systems? Are there any challenges or limitations in collecting data from those legacy OT systems at all? And how do you handle them?
In short, of course, it is a challenge sometimes, but the good news is there's a solution in any case. Because, let's say, in case of Splunk is a data platform, and if you have no data, there's nothing you can do, obviously. So you need the data. Sure. And there are many ways, let's say, you can access data from legacy systems, from modern systems. Of course, this is actually no problem, but from legacy systems, on the one hand side, you can, let's say, install the classic Splunk Universal Forwarder, which pulls the data from these environments. You can also actively leverage with several kind of, let's say, protocols. Yeah, you can use, for example, MQTT as the latest one, or Kepware and other ones. Of course, let's say, if all this still nothing works, then basically you just install some sensors, and you get basically sensor data out from these legacy machines. But so it's, of course, it always depends on the environment, but there's always a solution to it.
But it's not impossible.
We need the data, of course. Without data,
of course, that's right. Without the data, it's not really serving any purpose. I'll move on to machine learning then, and anomaly detection then. So, and I know this is something where I think Porsche are customers of Splunk in Germany and use this for predictive maintenance. But I'm keen to understand how Splunk is used for predictive maintenance or anomaly detection in industrial environment. And also, if you could elaborate on some of the use cases where that has proved to be, essentially building in the sort of resilience that we keep sort of alluding to.
Yeah, a very good point. You mentioned, I would say, the right term of machine learning, because nowadays it's called AI.
So, yes, I know.
Splunk
exactly.
has this machine learning toolkit in use since about 10 plus years. Yeah, so we have a very experienced team with machine learning, with out-of-the-box algorithms. So we're very experienced in this space. And of course, it's basically integrated in basically every kind of Splunk product. So it's integrated already with machine learning. And you mentioned the example of Porsche. We have also many other customers who use this, let's say, for a predictive maintenance. So in this case, for example, I would like to highlight our customer Zeppelin. So they used it basically to detect basically upcoming shutdowns of their generators in a power plant. And in this case, focusing specifically on power plugs. Yeah. So with the help of machine learning, we could basically detect when this power plug was going to fail. And of course, the customer could basically inform the technician in beforehand to replace this spark plug before the power plant was about to shut down. And because of this proactive predictive maintenance, they could save about 3-digit number, 100 number in euro of savings. Yeah, so it's real money they could save. Yeah.
And that was just through predictive maintenance and being able to identify when a problem had arisen or was about to arise before it did. And so they were able to maintain presumably production, I guess, is the key thing.
Another example of this predictive element of machine learning in the context of energy management. So in the case, let's say, of especially German manufacturers, they have a so-called a peak management, a peak load of their energy supply, which they agreed with their utility provider. So they have agreed price on this peak supply. And once they cross this peak energy consumption, the price basically triples or increases 4 times, but over a period of 6 months. Yeah. So by all means, they want to avoid crossing this threshold. And so with the help of machine learning, we basically can calculate in advance when this energy consumption is coming near to this threshold. And we alert then the operator, watch out.
Really?
So please reduce some operations to avoid crossing this threshold. So predictive kind of energy consumption is also a natural part of machine learning. Yeah.
Wow. I think I could do with some of that in my house when my sons are back from university and reducing my electricity bill. But that's another story. And presumably that was, you mentioned Bosch and how they'd been able to say, was it the similar sort of methodology that they adopted?
Yes. So for Bosch, we use this so-called peak management, and we also optimize their standby mode. Yeah. So basically, machines should always run when they're basically needed, and when there's no production steps basically upcoming, they can go back in standby mode. And yeah.
Wow. I mean, that's not insignificant at all, particularly when businesses are looking at trying to really, really reduce their overheads, isn't it? That's quite substantial. And we've sort of mentioned Bosch and Porsche, but what about other use cases where, or case studies where Splunk have provided real ROI? I'd be keen to know if you have any other examples that you can share.
Yes. Say, talking about business outcomes, I mentioned IT/OT security. I mentioned next generation operations with energy management. And the third one, actually, we haven't spoken about is service, business, and process monitoring, especially, let's say, for customers with SAP environments. And I'd like, let's say, to highlight here the example of our customers, BMW, and let's say a very nice story behind their Italian car dealer always used to call up the Munich headquarters and complain the Italian way that car delivery to his customer is late, and he has no idea why he's late. And of course, in Munich, they also had no idea why the car delivery is late.
Wow.
And now they installed Splunk, they installed some kind of vertical and horizontal kind of visibility. And with this, they could tell at any time where the car is in the supply chain on the way to the Italian car dealer. Yeah. So we basically very, very clear visibility into a business critical process. In this time, obviously, in this context, to sell cars. Yeah, where is the car, the delivery chain? Yeah, to of course, and this obviously increased a lot the customer satisfaction and the brand value, and also this kind of tangible kind of values. Yeah,
and keeping our friends in Italy very happy, which is really important. And so presumably then, in order to do that, you need to create specific dashboarding then, do you?
Yes.
Oh, right. Okay. And is there any limit on the types of dashboards that you can do? Or in terms of visualization, it's purely design. You can create whatever you want to meet your requirements.
Absolutely, yes. That's the beauty of Splunk. It's fully customizable in terms of business KPI, technical KPIs. You can basically show, let's say, the first kind of dashboards, the global view. You can drill down, let's say, to a country view, to a city view, to a business unit view, to the individual plant, and even down to the application and the device level. Yeah, and let's say, just to give you an idea of this granularity, speaking about energy management, of course, we can show the energy consumption of these big machines and of data centers and buildings, but they can even go down so granular up to the individual kind of Cisco device, showing the energy efficiency of a Cisco networking device. Yeah, so very, very granular. Yeah.
Okay, and what about challenges? I mean, because people, businesses inevitably will be listening and thinking, well, this all sounds great, but it's probably not that. You must have experienced some challenges with this sort of adoption across OT environments. I mean, what would you say are the biggest challenges you've come across?
You will be surprised to hear that technology never used to be the challenge. It's always, I would say, the human aspect.
The human, inevitably, yeah, of course. Well, is that the cultural change, is it? Cultural change.
Yes, and also in a way, because, of course, nowadays, complex challenges are always complex. It's not black and white or 0 and 1. There are always various kind of team members involved across different kind of functions. And I would say the challenge is always to get these people literally at one table, and get the right person who is in charge of that, to get his approval, to get access to this data source. This is a challenge, not the technologies.
Right, okay. So in terms of advice that you give to people, actually, that presumably would be in there, would it? Getting the right people around the table,
yes.
And making sure that they all understand what is happening, why it's happening, and what the business benefits are. Is that correct?
Yeah. Yes, of course. These people, they may have very different kind of objective and interest. For some, let's say, for a plant manager, obviously his key KPIs to have as high production as possible. So the OEE and in terms of, let's say, of an automotive plant, as many cars output per day. Yeah? And of course, if you want now, the CISO, the security manager, comes and says, oh, I want to install OT security, and for that, maybe you have to shut down the plant for 1-2 days. The plant manager won't be happy, obviously.
Really? It ain't happening. That's not happening. No, absolutely not.
It predicts his objective of the maximum car output per day. Yeah? So they have to agree on some kind of common objective to make this happen then.
Of course, compromise. It's the way ahead.
Compromise.
So I suppose last one for me then. What is the future? I mean, in terms of for OT more broadly, and where does quantum sort of play into this space?
Yeah, I mean, you said it. Quantum is definitely, I would say, the next kid on the block. Yeah, I mean, going hand in hand with AI. It has, of course, a certain kind of capabilities which I say are better or stronger compared to AI. And in terms of use cases, I would say especially 2 use cases: simulation and optimization. Yeah, the quantum kind of technology are very well suited for this kind of use cases. For example, I know Airbus is experimenting with new new technology for corrosion-resistant materials, and quantum is very suitable for this one. Or I'd say in terms of optimization, you can use also quantum, let's say, to optimize workloads or the workload scheduling in data centers, also to save energy in data centers. So a lot of upcoming use cases for quantum. Of course, quantum is well known, let's say, from the security aspect. Of course, there's this big news that they might crack the RFI encryption. Of course, but this is maybe a bit sci-fi. But the really tangible use case like simulation and optimization, I would say these are really very valuable and upcoming for manufacturers.
Okay. Oh, that's interesting. Well, Ewald, thank you very much for interrupting your day for the conversation. It's been great, and I think we have plans to have further discussions on other specific subjects in the coming weeks and months. So this is the first in a series of these discussions with experts like Ewald. Thank you for your time. Very, very much appreciated. And we look forward to the next time.
Thank you, John. My pleasure.